Good day! I am Casey Obalang from BSE 1H. So for today's lesson, I will discuss about introduction of graphs. So first, let's define what is graph. So graph is a set of points called vertices and line segments or curve called edges that connect vertices. So the purpose of a graph is to present data that are too numerous or complicated to be described adequately in the text or in less space. So it is also the common method to visually illustrate relationships in the data. So we have three different kind of graph. First is a simple graph. So simple graph is a graph that does not have more than one edge between any two vertices and no edge starts and ends at the same vertex. So in other words, a simple graph is a graph without loops and edges. So the second type of graph is a multigraph. It is a graph which is permitted to have multiple edges. It is also called parallel edges. That is, edges that have the same end nodes. Two vertices may be connected by more than one edge. And the third type is a pseudograph. Pseudograph is a non-simple graph in which both graph loops and multiple edges are permitted. So graph theory in mathematics means the study of graph. Graphs are one of the prime objects of study in discrete mathematics. In general, a graph is represented by a set of vertices, nodes or points, connected by edges, or arcs, or line. So graphs are therefore mathematical structures used to model pairwise relations between objects. They are found on road maps, constellation, when constructing scheme and drawing. Graphs underlie many computer programs that make modern communication and technological processes possible. So they contribute to the development of thinking, both logical and abstract. Let's discuss about Euler circuit and Euler path. So Euler circuit, a graph is a collection of vertices or nodes and edges between some or all of the vertices. When there exists a path that traverses each edge exactly, one such that the path begins and ends at the same vertex. So the path is known as Euler circuit. We should remember that Euler circuit uses every edge in a graph with no repeats, and a graph will contain an Euler circuit if all vertices have even degree. Euler path, a path that travels through every edge of a connected graph once and only once, and starts and ends at different vertices. So if a graph is connected and has exactly two vertices of odd degree, then it has at least one Euler path. Any such path must start at one of the odd degree vertices and end at the other one.
Chapter 6: The Mathematics of Graph. Constructing a graph to be discussed by Rose Angeline Barrowin and John Edward Benosa. Tribe 5 Hypotenuse.
So, good morning everyone. Now, let us tackle about constructing a graph. But before that, let us define what is a graph. A graph is a set of points called vertices and line segments or curves called edges that connects vertices. So, based from the definition, a graph is consist of vertices and edges to make the graph complete. Now, let us define what is vertices. A vertices of a graph is one of the objects that are connected together. It is usually indicated with a dot. So, the vertices is one of the elements to make the graph complete. It is usually a dot. Now, let us define what is edges. Edges that intersect with no marked vertex are considered to cross over each other without touching. So, the edges is the line that connects the vertices. So now, let us try to make a graph using this table. So as we can see, Matt is connected to Amber and Laura. So let us try to connect them. Matt to Amber, then Matt to Laura. Then next one is Amber. Amber is connected to Matt, Oscar, and Laura. Amber is connected to Matt. We will just put Matt. Then Amber is connected to Oscar. Then next is Amber is connected to Laura. Then next one is Oscar. Oscar is connected to Amber and Kyla. Then, Laura is connected to Matt and Amber. Then, lastly, Kyla is just connected to Oscar. Now, here's the perfect example of a graph. That's all for constructing a graph. Thank you for listening.
Next to be discussed deconstructing a graph is John Edward Benosa.
Okay, let's continue our discussion. As my group mates discussed earlier, the graph and Euler circuits, I will also discuss to you on how to construct a graph. Before that, may I define to you the meaning of graph. Graph is a set of points called vertices and line segments or curves called edges that connect vertices. Okay, question is how to construct a graph. Let's see the example table. As you see in the table, there are a list of 5 students of a college. An X indicates that the 2 students participate in the same study group this semester. So, as you see there are 5 students. First is Matt, second is Amber, third Oscar, fourth Laura, fifth is Kyla. Now, A. Draw a graph that represents this information where its vertex represents a student and an edge connects 2 vertices if the corresponding student study together. We draw 5 vertices in any configuration we wish to represent the 5 students. This is Matt, Amber, Oscar, Laura, and Kyla. And connect vertices with edges according to the table. Matt, connect with Amber and Laura. Amber and Laura. Amber, connect with Matt, Oscar, and Laura. Matt, Oscar, and Laura. And also Oscar connect to Amber and Kyla. Laura connect Matt, Amber, and Kyla to Oscar. Okay, D. Use your graph to answer the following question. Which student is involved in the most study groups with others? Which student has only one study groups in common with the others? How many study groups does Laura have in common with the others? So, as you see the graph, the vertex corresponding to Amber is connected to more edges than the others. So, she is involved with more study groups, 3 than the others. Kyla is the only student with one study group in common, as her vertex is the only one connected to just one edge. Laura's vertex is connected to 2 edges, so she's with one study group in common, as her vertex is the only one connected to just one edge. Laura's vertex is connected to 2 edges, so she shares 2 study groups with others.
Good morning, everyone. My name is Antoinette Miranda, and I'm from Chapter 5 Hypotenuse of BSED 1H. And today, I'm going to discuss about Euler path and Euler circuit. But before we proceed to our discussion, let me share to you the things which is most important to understand. Each of everyone us should appreciate the role of mathematics in our lives, because mathematics is the hidden secret in understanding the world. But not everyone loves math. Many students wonder why it's even necessary to learn in the first place. Well, it might not always be obvious, but math is really everywhere. For us to be able to understand math, we should change our perspective. And I'm encouraging you to appreciate math because it could be easier as long as you have the desire to learn more about mathematics. For you, what is Euler path? Euler path is a path that uses every edge in a graph with no repeats. Being a path, it does not have to return to the starting vertex. Here are some examples of Euler path. For example, if we start at vertex C, we go from C to B, B to A to C, And now, we have a problem. If we go from vertex C to F, we'll have to backtrack. We're using edge more than once to get back to B. If we go to B, we haven't used edge C to F. Our current path is not going to give us a Euler path. So, let's go ahead and try again. Remember the theorem, tell us if we have a path, it doesn't tell us how to find it. So now, let's begin at vertex C, going to vertex D, and then D to E, E to F. Let's go back to C, and C to B, B to A, and A to F. I think we found it. We started at vertex C, ended at vertex F, and we used each edge exactly one time. We had 1, 2, 3, 4, 5, 6, and 7. So, we can say that the Euler path would be C to D, D to E, E to F, F to C, C to B, and B to A, and lastly, A to F. Now, let's take a look at our second example. We'll begin by determining the degree of each vertex. Vertex A, F, and E has a degree of 3. Actually, we're done now because remember, we can have at most 2 vertices of odd degree. But this graph has 3 vertices of odd degree. So we can say that this graph does not have a Euler path. Now, let's revisit Euler circuit. Contain a Euler circuit if all vertices have even degree. We want to determine if each graph has a Euler circuit. And if it has one, we want to find a Euler circuit. We'll begin by determining the degree of each vertex. So, we have vertex B has degree of 2, vertex A has a degree of 2, vertex D has a degree of 2, and vertex E has also a degree of 2. But vertex C and F has a degree of 4. All vertices have even degree. Therefore, this graph has an Euler circuit. So now, we'll find an Euler circuit from a path using all edges exactly one time, returning to the starting vertex. So, if we start at vertex C, we could go from C to B, B to A to F, F to C, C to D, and D to E, E to F, and back to C. So again, if we number this, we'd have 1, 2, 3, 4, 5, 6, 7, and 8. So, we started at vertex C, went to B, to A to F, F to C, C to D, D to E, E to F, and back to C. So, the Euler circuit CB A F C D E and back to C. And you may have noticed this was a circuit is not unique. Looking at our graph, you can quickly see that vertex B has a degree of 2, but vertex C has a degree of 3. As soon as we know a vertex has an odd degree, we can stop. This graph does not have an Euler circuit. James Gordon said, "It's not that some people have willpower and some don't. It's that some people are ready to change and others are not." I hope you find this helpful. That's all, and I thank you.
Good morning, everyone. My name is Emmanuel Bermeja Abinal from Try 5 Hypotenuse. Now, I'm going to discuss about equivalent graph. What is equivalent graph? Equivalent graph, two non-isomorphic graphs are said to be chromatically equivalent, also termed chromically equivalent by Barry, 1974, if they are identical chromatic polynomials. A graph that does not share a chromatic polynomial with any other non-isomorphic graph is said to be a chromatically unique graph. Here are examples of graphs. Now, we are going to determine whether the two graphs are equivalent. In this graph, it contains 6 vertices, A, B, C, D, and E. And we are going to connect each edges by its pairs. First, A is to C. Second, A is to E. Third, B is to D. Next, B is to E. And C is to E. And last, D is to E. So, in this graph and these edges shows it is connected and they have no repeated edges. So, it means it is equivalent. We are going now in the second graph and determine if it is equivalent or not. The second graph contains 6 vertices, A, B, C, D, and E. In this graph, they have 6 edges. First, A is to C. Second, A is to E. Third, B is to D. Fourth, B is to E. Fifth, C is to E. And the last, D is to E. In these edges, it shows that they have no repeated line. Like in the first graph, it is equivalent.